started here. We're on lesson 1-2, and we're talking about the set of real numbers. Okay, so these should be in your notebooks. You should start writing your notes in your notebook, and then you should be on page 4 in your textbooks. Okay, I'm going to go through this review part a little bit quicker than the rest of the lesson because we do have a good amount. So when we were talking about rational numbers yesterday, we were actually also talking about real numbers. So I'm going to draw you a little Venn diagram. This right here is a set of numbers. We're going to call it the natural numbers n. Okay, so if you need like a key, you can write n equals natural. Yes, ma'am?
So you want us to draw this?
Yeah, if you could draw this on your paper, that help you out because you're going to compare these in a little bit. But the natural numbers, n. Okay, and then you had another category above that, the whole numbers, w. We didn't go over those in detail, but does someone remember what the natural numbers are? How do you naturally start to count your numbers? Yep, Josh? 1, 2, 3, 4, 5, so on and so forth. You don't count 0, 1, 2, 3, 4, right? You don't start with 0. So the natural numbers, 1, 2, 3, 4, 5, 6, 7. How many numbers are in that category, by the way? Infinite. So it keeps going. Whole numbers, where do those numbers start? Chelsea? 0, 1, 2, 3. So can you see from this little diagram that all the natural numbers are also whole numbers? Can you kind of see that? Are all the whole numbers also natural numbers? No, because there's one big one. It's the number 0. Okay, the next category, which is a familiar category for a lot of you, the integers. Does anyone remember what the definition of integers are, or is? The definition is, Parker?
Any whole number is opposite.
Yeah, so it has all the whole numbers, but it also has the whole numbers opposites. We're going to talk about opposites today. What's the opposite of 10? Negative 10. What's the opposite of negative 25? Positive 25. All right, I'm going to give you some help here to give you some preview of the lesson. What's the opposite of negative 4.5? Positive 4.5, or just 4.5. Okay, so you guys get that. All right, and then the main part of yesterday's lesson was dealing with rational numbers. And I'm going to use the letter R. There are technically other letters you use, but I don't want to get too bogged down with those definitions. And in 7th grade, I did go through that more. But those are rationals, R, rational numbers. What's a rational number? Bella gave us the definition. I need someone else to give me a definition. Josh.
A over B form.
Where B doesn't equal 0. So basically, any number that can be written as a fraction where the denominator does not equal 0. You cannot have that. Okay, but do you remember there was a second category really we looked at yesterday? What was that second category? This is the rational category, and then there's the irrational category, and I'll use IRR. So irrational category. All right. If you're a rational number, can you be an irrational number at the same time? No, and vice versa. But I still haven't talked about real numbers because the real numbers includes both the rational numbers and the irrational numbers. So we'll call this the real numbers. So is a rational number a real number? Yes. Is an irrational number a real number? Yes. So, Mr. A, rationals and irrationals are real? Yes. How many of you kind of wonder, why do we call them real? Because these are not all the numbers, by the way. You deal with other numbers. They're not going to be a real number category. They're going to be called the, does anyone want to take a guess at what the non-real numbers are? Raise your hand. Raise your hand. Bella, what do you think?
Fractions?
Okay, fractions would be a rational number, and they'd be a real number. So what would the other category be called? Yep. What do you think? Just anything? It's a real, usually someone said it, real or fake, right? The fake numbers, you're going to deal with fake numbers. But that's actually not the name. The name is the imaginary numbers. So the ones that you imagine up here. Okay, real numbers, real quick definition, just so you know, and we'll stop with that categorization. Real numbers are numbers that can be graphed on a number line. So if you have a number line and you could put a dot where one of these numbers is, it's a real number. Imaginary numbers, I look at a number line, can't put it on that number line. So that's just the definition. You'll get to that more in Algebra 2, a little bit at the end of our year. Okay, let's look at what I kind of alluded to, the number line. Yes, sir?
Are these first two classes people longer or shorter?
No, they're same amount, yeah. About. I think there's minutes or so. Is this class going too long? Like, oh man, Mr. He's only talked for 20 minutes. No, it's been about 5. Okay, but anyway, let's. But here's a little help for some of you who maybe time drags on, and I do this myself. When you look at that, you notice I don't have a clock in here, because when you look at that clock, guess what happens to time? Slower. It does not fly by. Oh my goodness, a minute passed by.
Seriously? What?
The minute hasn't even passed by. So stop looking at your watch or your clock if you want time to go faster. If you want it to go slower, yeah, check it out. Because it will go slow. All right, ordering real numbers. So this is where we're going to get into your actual problems. Ordering real numbers. Okay, let me give you a set of numbers. And I want you to give me the order from least to greatest. Okay, so you're going to go from the smallest number to the largest. And here are the numbers. The square root of 2, comma, that's how you separate the numbers, negative 3 4/5, comma, pi, comma, 2, and negative 1.7. Ooh. You don't have to thank me for this list of numbers yet, because some of you are looking at them and you like 2, and you're even okay with negative 1.7 maybe, or negative 3 4/5. But why did I give you those two numbers? Okay, we're going to list them from least to greatest. A very nice way of ordering them is to use a number line. And in your workbook, they actually have a number, and you can put the numbers where you want, so you can kind of get them arranged, and then erase your work and do it for the next problem. So they give you a big number line you can use, which is really nice, so you don't have to keep making number lines. Okay, so here I'm going to start with, I'm going to go negative 4, negative 3, negative 2, negative 1, 0, 1, 2. I'll just go to 3. Okay, so here's my number line. Again, you'll get a long number line on your assignment, so you can use that for reference. Okay, I'm looking at these numbers right here. I'm saying, yes. Can you guys graph 2?
Yeah.
I hope so. You put a little dot, and I know this seems redundant, but I'm just going to put a 2 up there, because that's the point for 2. I'm going to put the points where they belong and put the numbers above it, and then I'll be able to see very clearly the least to greatest. Okay, which one would you want to do next? Just raise your hand. Yes, ma'am?
Negative 1.7.
Negative 1.7. All right. 0. Negative 1. Negative 1.7. Right about here. And if you're not comfortable doing that, this is great practice for that. If you're super comfortable doing that, great practice for that. Look at that. Okay, so we're done with this guy. We're done with that guy. And what would you want to do next?
Negative 3 4/5.
Negative 3 4/5. So here we have 0, negative 1, negative 2, negative 3, and 4/5 right about here. Negative 3 4/5. It doesn't have to be perfect. I'm not grading the points. I'm grading the order at the end when we get it. Bless you. Okay, I have these two gone, and I'm done with negatives, which is really nice. Okay, I think that maybe you'd want to do pi first, because what's pi about?
3.14.
3.14. But remember, Mr. A, pi is irrational, so doesn't it keep going on forever? But can you kind of estimate on this number line where 3.14 might go? So let's see. 1, 2, 3. And again, I'll go 4 here just to help some of you out. Maybe 3.1. So I'm going to put pi up there. Isn't it about right there? Okay. So pi's done. Whew. The square root of 2. Yes, sir.
What does that last number say?
4. It's this little thing.
Up there, like under the S numbers. What's that?
This one?
No, under the S numbers, that thing right there. What is that? What's that?
Negative 1.7.
Oh.
Okay, sorry. I'm glad we got that cleared up. That's okay. All right, the square root of 2. Remember yesterday we were trying to find out, okay, is 2 a perfect square?
No.
No. So is it going to be a terminating decimal or some kind of decimal that goes on never non-terminating? It's going to be non-terminating. But where would that go? So what 2 perfect squares is the square root of 2 roughly between? Cole?
1, 2, or 1 and 4.
Yeah, so it'd be between, and I'm going to write work right here if you need it, the square root of 1 and the square root of 4. This would be 1, this would be 2. Anyone remember that? Okay, and then this is your number line. The square root of 2 would go closer to 1, maybe like right there. So here I have my number line, 1 and 2, right about there, square root of 2. Is that kind of where it should go? Does that kind of make some sense? And you did this yesterday, so it's kind of review for that. Now, is it pretty easy to order these numbers once you get them on that number line? Yeah, here's my answer. It's this. I'll put commas to separate them. That's my answer. It's negative 3 and 4/5, negative 1.7, the square root of 2, 2, and then pi. That's the order. I'm not saying you must use a number line, but it is available for you to use. So on your homework assignment, you have this giant number line, and you can put little dots in the numbers for the first problem. Once you get this done, just erase it. So I would recommend you don't write too dark on that paper because you can keep reusing it. So it's up to you. Yes, sir.
Is that how we should work?
Yeah, and see, here's the thing. I'm going to require this for your homework, but I'll say the number line, and that's the hard part about using a workbook. Yeah. Yes, sir.
Can we do the number line in our workbook and then just write the answer?
Yes. All right, how many of you kind of get how to order numbers on a number line or order them? You kind of get that? Okay, if you don't, that's okay. I'll work along with you, but I'm going to give you one problem. It's number 3 on page 5 on the very bottom. You see number 3? Graph the numbers on a number line. You can do that. You don't have to. Then write the numbers in order from least to greatest. So here are the numbers for number 3. Negative 5.5. Negative 2.2. Negative... Oh, I'm so sorry. That is not something I wanted to show you right away. Number 3. Negative 2.2. Square root of 9. 0. Negative 5.5. Negative 1.3 repeating. So go ahead and try to get those ordered on a number line. Forget what I put first. Oops.
5 over 2 is 5.5.
Oh, I'm sorry. Negative 5 over 2. If I said differently, I apologize. Negative 5 over 2. Now, numbers like the square root of 9. Do I know that has another value that I can state? What's the square root of 9 worth? 3. So isn't that easier to use? But in your answer, you need to put the square root of 9, where it goes in that order. And then negative 5 halves, you can write that differently, but in your answer, you need to put negative 5 halves. And same thing for negative 1.3 repeating. It is negative 1.33333 ... but you need to write it the way they wrote it. And if you need help, I'll do it up here. If you don't, you are okay. Oh, 0. Thank you. Done. Square root of 9, 3. Thank you. I can do that one. Negative 2.2, negative 1, negative 2.2. Okay. Done. Negative 5 halves, what is that worth? Negative 2.5, or negative 2.5. Negative 2.5. So that goes right here. If you don't have a ton of space, you can write below. Just whatever it takes for you to get it. I'll write it right here, very small, really close to that dot. And you can do arrows, whatever it takes for you to remember. Okay, and then negative 1.3 repeating. You can't put that on a graph. It's repeating. Where would it be approximately? Tell me when to stop. Okay, good. Please tell me to stop here. Negative 1.3 repeating. How many of you got this order? Negative 5 halves, negative 2.2, negative 1.3 repeating, 0, the square root of 9. You got that order. Even if you didn't use a number line or if you did use a number line. Okay, how many of you have questions on that? Like, Mr. how did you put this here? Why was that there? Or no, that does not go there. You just have a statement. Okay, you'll be doing that on a few problems to help you out. Yes, ma'am?
How can you figure out that negative 5?
Halves?
Yeah. Is 2.5.
Yeah, this is an improper fraction. Do you remember how to turn it into a mixed number? Just divide. 5 divided by 2. Okay, and that's negative. And don't forget those negative signs. They're just as important as the numbers themselves. Sorry, he was done. Okay, you guys okay on that? Whew, almost done here. All right, just a little bit of review. We're talking about absolute value. These first lessons are a lot of review, so the topics are a little more spread out, but hopefully they're not too difficult. Absolute value. Okay, yeah, I'll put this down. The absolute value of n. That's how you say it. Absolute value signs of n. How do you know that's not a 1, Mr. A? Well, because those lines are supposed to be pretty long. So you can kind of see that this is not a 1, and you have it on both sides. We call this the absolute value of n. What does that mean? Is the distance, and this is going to be technical, but then we'll use examples. It's the distance from 0 on a number line to wherever n is, whatever number n stands for. And like I said, it's on a number line. By the way, guys, can I ask you a quick question as you're writing it, or if you've already written the definition? Do you ever give a negative distance? Do you ever say, I went negative 5 miles to the park? It takes me, and really with a lot of other things, you don't use negative numbers. So distance is always positive. And if you can remember that, absolute value is not too bad. Okay, so let's see if we can get these couple examples here. The absolute value of 3.5, or 3 5/10. Okay, what is the value of the absolute value of 3.5? It's 3.5. Okay, that's nice. And I'll show you on a number line what we're even talking about in just a moment. Does anyone know what the absolute value of negative 3.5 is? What's the absolute value of negative 3.5? Yeah, I heard it. It's 3.5. What? Wait, that's positive, that's negative. Yes, ma'am?
Is there ever a situation that the negative sign would be on the outside of the absolute value?
Yes. Oh, yeah. And we'll have to get to that in just a moment. Yep. Okay, here's 0. And I'm going to go here with 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Now, guys, we do have quite a few number lines in this lesson, but take heart. You will not have to do number lines for the rest of your career. In fact, after a while, you're like, man, there's a way easier way of doing it. Great. Yeah, you don't need the number lines anymore, but they're helpful for explaining some concepts. Okay, the absolute value of 3.5. All right, 3.5 would be about here. What's the distance between 0 and 3.5? What's this distance right here? 3.5. So do you see that the absolute value of 3.5 is 3.5? Okay, but what's the distance between negative 3.5 and 0? So negative 3.5 is right here. What's the distance from here to here? It's still 3.5. So that's what we're talking about with absolute value. And there are a lot of good applications. You're like, why do we even do absolute value? Because we use it so much, it's very helpful to explain right now. Okay, you guys okay with that? All right, let's do some verbal feedback here. Everybody, what's the absolute value of 12.8?
12.8.
What's the absolute value of negative 5?
5.
What's the absolute value of 12 and 3/8?
12 and 3/8.
The absolute value of negative 1.7.
1.7.
Okay, you guys are good on that, right?
Yes.
And I think, was it you, Sophie? Is there ever a point where you'll have a negative sign? Okay, ready, guys? Don't write this in your notes. I don't want to confuse the notes. But what if I did this?
Negative.
What's my answer here now?
Negative.
It's negative 3.5. You're like, wait, Miss Ray, you just said they're always positive. Okay, look at what we're saying here. The absolute value of 3.5 was 3.5, right? Positive. The opposite of the absolute value of 3.5 is negative 3.5, right? What's that answer now? All right, so what's the absolute value of negative 3.5? 3.5. What's the opposite of that absolute value? It's negative 3.5. Yep. Now, let's talk about that little sign right here. Look, this guy gets special treatment today. I'm going to put this, you do need to have. This will help you out. And I did it like this symbol. What does that symbol mean when you were in second grade? Subtraction. A lot of people say minus, right? You just say minus. 5 minus 2. And you still say it with minus. But then you guys learned maybe 5th grade that sign can also mean in front of a number. It can mean negative. Yep, negative. So, yep, that's what it can also mean. And today, Mr. A used it slightly differently. He used the word opposite of. And it's opposite of. Okay. You said, maybe you remember this. I said algebra makes things easier. And right now I just made it more difficult. Okay, so which one is it in a given time? Okay, ready? How do you think you would read that symbol? 5 minus 3. Okay, you just say 5 minus 3. How would you read this symbol?
Negative 10.
How would you read it there?
Opposite of negative 10.
Okay, yeah, some of you simplify that. It would be 10, but the way I read it is the opposite of negative 10. Do you see how I put that? Opposite of right here, negative right there. It depends on the context. It depends on how it's written. Now, guys, I don't want to get too deep here. I'm not going to confuse you. Either one of these can be used for any one of those examples. Any one of them. Let me give you one example real quick. Okay, remember this negative 10? You're saying, Mr. A, you can call that minus 10? Okay. Yes, I can. What's 0 minus 10? Negative 10. So that's possible. Opposite of 10?
Negative 10.
Negative 10. Do you see how you can use it in that example? All 3 ways? 3 ways? Okay. So that's your negative sign. You will need to know that. Okay. Let's move on here. Sorry, guys. We're moving kind of fast, but I don't want to bog it down. Now we're going to talk about additive inverse. Oh, is that like a disease or something? Additive. Some of you are saying, of course it is. It's math. Additive inverse. We have used this before, but not as much, and that's okay. 3.5 and negative 3.5 are additive inverses. So we have already used these numbers. These are just an example of it. 3.5 and negative 3.5 are additive inverses. How else can we describe 3.5 and negative 3.5? We've used this term before.
They're integers.
Okay, they're integers. Yep, this is an integer. Good. That's an integer. And they are opposites. Do you guys remember that? Opposites. So 3.5 and negative 3.5 are additive inverses and are opposites. Which leads me to the conclusion that opposites are additive inverses. Additive inverses are opposites. Okay? So let me give you a little quiz here, verbal quiz again. 3 and negative 3 are additive inverses. True or false?
True.
Good, true. 3 and negative 3 are opposites. True or false?
True.
True. Okay. Give me a number, Elizabeth. Any number. It's not too long because I can't remember. 5. What is the opposite of 5, Annie?
-5.
What is the additive inverse of 5, Jack? Additive inverse of 5. Whoa, you guys are quick. So can I use either term to get the same number? Okay, Callie, what is the additive inverse of -7?
7.
7. Sophie, what's the opposite of -7? Do you see how they're the same term? You can remember them as either one. So why did I even bring that up? Okay, additive. What is that operation? Addition. Here's a little fact. Okay, so this is a fact from these two numbers. What is 3.5 plus -3.5? Anyone know? 0. -7 plus 7. What is that? 0. What is any number plus its opposite always going to give you? 0. What's any number plus its additive inverse going to get you? Wait, that's not that cool, is it?
No.
It's very cool. Very, very cool. Super, super duper cool.
Are you calling math cool?
Of course, yeah. But I am also calling science cool, history or social studies cool, language arts cool, art cool, PE cool, lunch cool.
Oh, yes.
Break. Don't forget break.
And after school.
After school's nice. Spanish is language, any language, yep.
Spanish is fun. I need my book back here.
All right, this last thing and we're done. Value of an expression. Value of an expression. Okay, so taking what we know now, we're going to be able to find the value of an expression. Do you notice I did not use the word solve? Are we solving anything right now? No, we're finding the value of an expression. Okay, so here I have an expression. And we're not solving because there's no unknown. Like we know what these numbers are. There's no variable, so you're not solving for anything. But you are multiplying. I'm trying to make this emphasize here. You're multiplying. You're multiplying this number by this number right here. Okay, can anyone read this number for me just the way it is? You think you can read it the way we kind of talked about? Cool?
The opposite of -30.
Okay, the opposite of -30. You know what? That I can read that, but how can you write it easier? Yep.
30.
It's positive 30. The opposite of -30 is 30. So why don't you just write 30? Okay. Can someone read for me the second number? Yes, ma'am?
Opposite of -12.
Opposite of -12. What is the opposite of -12? Yes, ma'am? Positive 12. And what's going on between these two? They're being multiplied. So really, when I multiply it, and this is a mouthful, I hope I can say it right. The opposite of -30, if I'm multiplying the opposite of -30 by the opposite of -12, that really means I'm multiplying 30 and 12. Okay, 30 and 12 would give me 360 would be my answer. So you have to be able to go from here down to here. Okay, so that's one problem. Last problem we'll do together. Someone read to me this problem right here. Yes, Sarah.
The absolute value of 6.9 minus the absolute value of 2.9.
Mm-hmm. Absolute value of 6.9 minus the absolute value of 2.9. Okay, so I know it's this minus that. What is the absolute value of 6.9? Yes, sir? 6.9. What's the absolute value of 2.9? Yes, ma'am?
2.9.
Wow, 2.9. Minus. What do I get?
4.
Okay, don't forget when you're subtracting or adding decimals, you line them up. If you're like, how'd they get 4? They did this. 6.9 minus 2.9. Lining up the decimals, I get 4. I got it right here. 4. Yes, ma'am?
I remember last year, we worked with the negatives, and I don't remember if it started this one when we changed the
Yes. Mm-hmm. We're going to do that tomorrow. Yep. Who thinks they get how to do this? Like if I give you problems, maybe you can't do it right away, but you can get to it. Okay. I'm going to have you do this last problem by yourselves, and then I'll write down the homework while you're doing that. It's on bottom page 5, number 5. Find the value of that expression, number 5, and I'll write your homework up here. You can start on that when you're done. Right, so once you get done with that problem, go ahead and start your homework on that separate piece of paper, and then I can come around and after a while, once everyone's done with that example, we can talk about it real quick.
I'm on the right page.
Yes, that's a good thing. Remember, this homework is in the workbook, so your soft cover book will have page 4, 14 to 30 even.
Did we say it? 'Cause